3 over 2, right? But I'm good there because I was taking positive and negatives. And I need this one that's got a reference angle of pi over 6 for the third quadrant. 7 pi over 6. It's also the negative square root of 3 over 2, but that's all right because I had that. And then I need this last one where I get the other positive value for the square root of 3 over 2. 11 pi over 6. Good. And I didn't write it down, but in my book it said that I was supposed to only solve this in the interval from 0 to 2 pi. So we've got all of them. Okay? So sometimes you can just, if there's not an x squared and a something to the first power there, you don't have to do the binomial thing. Checkpoint 6. So like I say, always look for things where you can use the greatest common factor and factor something out. What I notice here is I've got two terms, right? And the sign of x is in both terms. So if I had them on the same side of the equation, I could factor out the sign of x. So I'm going to subtract the sign of x from both sides, just because I want it all on one side of the equation. So I've got the sine of x times the tangent of x minus the sine of x. So you look to see, is there a trig function that's in common with more than one term, and pull all the terms that have that one on one side and everything that doesn't have it on the other side. And once you have it like that, then see how I can factor. I can factor out the sine of x, and I've got tangent of x left out of this first term, minus what's left out of this term when I factor out the sine of x. 1. Good. Doesn't just disappear, right? And once you have it in factored form, whether you use the binomial idea or not, this says that these two things multiply together to give me 0. What does that mean to me? Each one could be equal to 0, so I'll take the sine of x and set it equal to 0. And I'll take the tangent of x minus 1 and set it equal to 0. And once I have them split apart like that, now I can do what I've been doing and just solve this. Because this says that I want x's that give me an arc sine value of 0. Well, remember the sine is y, right? So here and here on the unit circle, that's where y is 0. So 0 and pi are my two solutions for that one. This is the angle of 0 and this is the angle of pi. And then over here, this tells me that the tangent of x is equal to 1. So x is the arc tangent of 1, which is what? Tangent is opposite over the adjacent. So remember, it's the one where they're the same. Pi over 4. Okay, but I do need the other place where tangent is a positive 1. So I've got this one. Where else is tangent positive? In the third quadrant. So I need to know what that angle is. It's got a reference angle of pi over 4. 5 pi over 4. And I don't have to find any more because I am just going to 2 pi. So I don't want to wrap around anymore. So those are the ones that are fairly straightforward. Just use algebra, basically, is all you use on those. and the idea of the reference angles. In the next set, we talk about the ones where we actually have to do some trig stuff to it. We're actually going to have to use identities to be able to solve these. So we have 2 times the sine squared of x minus 3 times the cosine of x equals 0, when x is between 0 and 2 pi. Now I want you to notice right here, right away, I got a sine and a cosine, and I don't have anything in common, so I can't like factor anything out. I can't do the quadratic equation, right, because the square of cosine is not sine squared. Yes? So anytime you have something like this, and look for these things, the sine squared can be replaced with something from the Pythagorean identities that had to do with the cosine, right? Remember, sine squared plus cosine squared is always equal to 1. So I can replace that sine squared with the phrase or the expression 1 minus the cosine squared of x. Everybody see what I did? So I've used this identity, so now I've got everything in terms of cosines. Now when you distribute through, you get 2 minus 2 times the cosine squared of x minus 3 times the cosine of x is equal to 0. So if we put it in descending order and put it all on the other side, I get 0 is equal to 2 times the cosine squared of x plus 3 times the cosine of x minus 2. I don't ever like my leading term to be negative, so why would that 0 be a 2? Okay. All right. Now this goes back to the fact that now I have this, it's quadratic in form, right? So I can do my u substitution idea. So if you use the cosine of x, what's u squared? Cosine squared of x, right? So this is 2u squared plus 3u minus 2. And I can see if this will factor, right? Do the bottoms up. I'll take this 2 and multiply it over here. Are there 2 things that multiply together to give me negative 4 that add together to give me positive 3? Positive 4 and negative 1? So I get u plus 4 is equal to 0. And u, whoops, I don't either. Do I? What did I forget? I multiplied by 2, therefore I have to divide out the 2 before I set it equal to 0. So I have u plus 2 equals 0, and u minus 1/2 equals 0. So u is equal to negative 2, and u is equal to positive 1/2. But what is u? The cosine of x. So you're going to take your u substitution and replace it back with your trig function. And now the x is equal to the arc cosine of negative 2. What angle gives me a cosine value of negative 2? I'd really like somebody to remember the range of the cosine function. What's the biggest number you can get for just a cosine function? 1. And what's the smallest number you can get? Negative 1. So what's my solution here? Nothing. There is no angle that gives you a cosine value of negative 2. Okay, so that one doesn't give me a solution. So you just mark that one out. I still have this other one that's going to give me a solution, right? That's called an extraneous root. Y'all remember those from algebra? Didn't do anything wrong. We just got something that doesn't actually apply to this situation. Okay? And so the cosine of x being a half means that x is equal to the arc cosine of a half. Does anybody remember what angle gives me a cosine value of 1/2? Pi over 3. And not only does pi over 3 that's in the first quadrant give me a positive 1/2, the angle who has a reference angle of pi over 3 in the fourth quadrant, right? Everybody understand? All smart trig classes, cosine's positive here too. And so if I'm at 2 pi and I want to make it as something over 3, that's 6 pi over 3. So if I subtract 1 pi over 3 off that, that leaves me pi over 3, exactly like Caden said. And again, that was told us that we only wanted our angle measurements from 0 to 2 pi, so that gives me all of my solutions. Huh? Wouldn't think so. Alright. There's just several of these where you use different identities to solve these equations. But I want to go ahead and move on over because we're about to run out of time to objective 6 so that we can get finished with this. And on objective 6, no longer are they going to give you these special angles that we know the answers to, their exact values. These are going to be problems where they actually give you something where you've got to put it in the calculator and find a decimal approximation. Okay? So, checkpoint 11. Have the tangent of x is equal to 3.1044. And part B tells me the sine of x is equal to negative 0.2315. Okay? Good. Good. Okay. So, these aren't special angles. You know that immediately, right? Because it's not a not a nice rational number. So, x is equal to the arctangent of 3.1044. Do you remember how to put that in your calculator? You hit the second button, then the tangent button, and then you type in 3.1044. And then hit enter, making sure you're where? In radians, right? What'd you get? Usually we go to 4 places past the decimal when we're using the trig value, and we go four decimal places. Okay. Okay, so we're in radians. Now, same idea. What did the calculator give you? When you had a positive argument and you're doing the arc tangent, what angle did they give you? What quadrant was the angle in?